Okay, here in this video I'm going to show 3 examples. The first one's going to be pretty easy, so don't think the other ones will be like it. The other ones is where you'll have the radical, and one of the sides will have a radical or a number on it, so pay attention to those. Okay, here we go. So the first one, right, we're learning we have the new 3 trig ratios, right? We know sine, we know cosine, we know tangent, and then once we have these, we have to know how to pair them up, right? So that's been the emphasis on the first 2 videos. Which one pairs up with tangent? Cotangent. Which one pairs up with cosine? Secant. Remember, they cannot start with the same first letter. This one starts with a C, this one cannot start with a C. And this one is going to be cosecant. Okay, and they're reciprocal identities. Okay, so let's jump into a problem that you'll see here. So the example in the notes, right, will be something like this. Again, remember, this is for right triangles, number 1. So fortunately right here we got all the sides, you don't have to look for them. And we got the angle up here. Angle up here, that makes, well, this one's the hypotenuse side. Let's label that H. That makes this one the opposite side. And this one the adjacent, right? We have to always get the sine, cosine, tangent first. Even though they're just asking you for one of these, believe me, you should just find them all anyways. Okay. So we're going to find the first 3 from sine, cosine, tangent. And we know we use sine is so, S-O-H, so that's O over H. Cosine is ka, we're going to use A over H. And then tangent is toa. Right, we already know this. So sine is going to be O over H, 5 over 13. That's always check to reduce, but that one doesn't reduce. Cosine is A, which is 12 over H, which is 13. That one doesn't reduce. And tangent is O, which is 5 over A, which is 12. And always check to reduce. That doesn't reduce. And then now, the only thing you got to do is know how to pair them up, like we talked about up here, or like what was talked about in the first 2 videos. So then all you got to do now is, right, these are the first 3. What are the next 3? Well, I pair them up. Sine is cosecant. Cosine pairs up, or reciprocal identity is secant. And this one's cotangent. Right? And again, luckily there was nothing to reduce. And now, once you know these 3 and you pair them up, the ratios for these 3 new ones is the reciprocal. They're reciprocal identities. This one's 5 over 13. This one's what? 13 over 5. Cosine is 12 over 13. That means secant, which is paired up to cosine, is a reciprocal identity, would be 13 over 12. Flip it around. 12 over 13, 13 over 12. And then tangent is 5 over 12. That makes cotangent 12 over 5. Okay, this one's pretty easy. The next 2 are going to have the square root, the radical, and that's going to bring up a couple of new issues. So make sure you watch these following 2. Oh, here's the next one, number 2. Kind of the reason why I went fast on this one. I really want to slow it down for numbers 2 and 3. Okay, here's number 2. Got a triangle like this. Remember, this is only for right triangles. Okay, we got our angle here. This side is 4 root 5. There's my radical there. This one's 12. This one is 8. Okay. So for this, here's where you got to pay attention. Well, let's label the sides first, right, before we start anything. We got all the sides. This is the hypotenuse side. That makes this the opposite. It's opposite of the angle. The 8 is your opposite. And this will be the adjacent. Okay. So we'll do sine, which is so. We'll do, oops, forgot the little angle sign. We'll do cosine, which is ka. And what you always got to find these first. You just always got to get those. So ka toa is O over A. So sine is going to be 8 over 12. And cosine is going to be A 4 root 5 over H 12. And then tangent is going to be what? O 8 over 4 root 5. Yeah. Okay. So what we can do right now that I notice here, see, we can reduce these. Always look at the whole numbers. Always look at the whole numbers first. If we can reduce it, let's reduce it. So I'm going to write it over here. Sine is going to be what? 8 over 12. If you reduce by 4, if you reduce by 4, that would be 2 over 3. That's 4 times 2, and that's 4 times 3. Yeah. So I'm just writing it over here. Cosine would be what? Again, you can all. So we're going to keep that square root of 5. That's going to be in the answers. You reduce the 4 and the 12. 4 goes into 4 once, and 4 goes into 12 3 times. So if it's a 1, you don't have to write it. You can just put root 5 over 3. That's what you will see, just square root of 5 over 3. If it's a 1 right there, you don't need to write it. And then tangent is what? And if I reduce the 8 and the 4 by 4, you'll get a 1 here and a 2 here. So it's tangent will be 2 over root 5. Okay, so always check. If you can reduce it here, go ahead and reduce it, only the whole numbers. And then you don't have to reduce it like another time when you do the other 3. Okay, so now, what is the reciprocal identities, or sometimes they call them reciprocal functions? Well, again, I like to start with tangent. Tangent is cotangent. And then I start up here. Sine is cosecant, right? They can't start with the same letter, and this one's secant. And there's going to be something new that's going to happen here, so pay attention. Go ahead and do all the reciprocals. So that'll be 3 over 2. That'll be 3 over root 5. And that will be what? Root 5 over 2. Do all of this first. I mean, obviously, if anything, reduce the whole numbers and then do all of this. Okay. Now, here's where this is going to come up. I'm telling you, it's going to come up every time when you have this radical, the square roots. I did them all, right? They're pretty good. They're all correct. Well, I did everything so far correctly. Now what you got to check. I don't have a problem with these because these are all whole numbers. 2 and 3 and 3 over 2, they're fine. But the ones that have the radical, you have to fix. We did this before. You have to fix now. Wait, leave this for last, okay? Do it exactly like this. Get these 3, reduce them if you can. Then you do the reciprocal, and then you do these 3. But the ones that need to get fixed, remember, if it has a radical, this root here, like the square root of 5, if it's in the numerator, it's okay. But which ones do we have to fix? When it's in the denominator. You see? But do that till the very, very last. Do this all. See, so don't try to fix it here before you get cotangent. Just get them all out first, and then you take a look last and see which ones need to be fixed. These two need to be fixed. This one's fine. It has a square root on the top. This one's 5. It has a square root on the top. Anybody remember how to fix this? Yeah, we multiply by the square root of 5 to the numerator and to the denominator. And actually the same thing over here, right? Because that's the root. We don't want to get it. Okay, so then finally then for tangent, your tangent, after you multiply this, the square root of 5 times the square root of 5, see, now you made the whole number 5. The square root of, and then the top is just 2 root 5. Remember, this 5 cannot cancel with this 5. Right? This is not a 5. It's inside the radical. Only the whole numbers. Always check the whole numbers again. See if that can reduce. It can. So now this is the correct ratio for tangent. The other ones we didn't have to fix, but we also had to fix secant. So if we fix secant here, we multiply that and we multiply that. The secant ratio is the square root of 5 times the square root of 5 is a 5. See, we wanted that to happen. And 3 times root 5 is 3 root 5. Okay, all these other ones are fine. You don't have to worry about that radical in the denominator. But these we did have to worry about it. All right, let's look at one more. Number 3. I was gonna put it on the other video, but I just didn't want to make too many videos. All right, let me do it quick then. So this is what I'm telling you. Here's number 3. It's kind of a little tilted like this. So that's how they kind of rotate the triangles and try to fool you sometimes. Don't be fooled. Look at where the right angle is. Okay, so draw it like that. Here's what the sides are. This is 6 root 2. This is 3. And this is 9. Okay, a couple of new things are going to happen on this one. Let me do sine, cosine, tangent first. So, COT. Oh, you know what I forgot? Which one's the angle? This one. Got to make sure I indicate that. Yeah, you know, before I do all this, I got to label my sides. I'm getting ahead of myself. Which one's the hypotenuse side? It looks like it's this one, but it's not. It's this one over here. This is your hypotenuse side. That's H. This is your what? Opposite side. It's opposite of the angle. And that makes this one adjacent. Okay. So I know sine is O over H, so that's sine is O over H, so that's 6 root 2 over O over H. Over H is 9. Okay. Cosine for the cosine is A 3 over H 9. And tangent over here, I'll bump it down. Tangent is O over A. O, which is 6 root 2, is O over A, which is 3. And so like I said, and what's happening here, like it happened on the previous problem, always look at the whole numbers and reduce here, because if you don't reduce here, then the other ones won't be reduced, and then you got to reduce 6 instead of 3. So let's reduce the whole numbers now. These can be reduced. The whole numbers can be reduced. So really my correct sine ratio after I reduce sine, if we reduce by 3 and by 3, that will be 2 root 2 over 3. Right? This is my sine ratio. Can't reduce it anymore. Okay, that's it. Oh, you know what? I shouldn't do that now. Cosine, I can reduce cosine. Cosine is what? Reduced by 3 is 1 over 3. 3 goes into 3 once. 3 goes into 3 9. And then tangent. Tangent is going to be what? Reduced by 3, it'll be 2 root 2 over, right? 3 goes into 3 once, 3 goes into 6 twice. 2 root 2 over 1. Believe me, leave it like that. Okay. Now, even if you have one of these with a radical in the bottom, don't fix it. Get these other 3, right? The 3 new ones, the reciprocal identities, get those first. What's the reciprocal identity of tangent? Cotangent. Got to get that right first. What's the reciprocal of sine? Cosecant. Hold on.